Okay, this is our second lesson in 7th grade, and it is entitled Properties of Operations. Basically, we're going to go over a bunch of different properties that the students have used before, but they probably didn't realize they had been using them or what they were called. So we're going to go over a bunch of them, and we'll sum them up at the end, and hopefully by the end of all this, we'll have a little bit better understanding of these certain properties that they use all the time. So let's jump into it here. The first thing that we need to talk about is inverses. Inverses, especially later on in their high school careers, are going to be something that they use quite a bit. They're pretty important, and starting this year already, obviously, they are going to be using them. I told the students to think of them in a certain way. The whole idea of inverses is kind of like undoing something. So if we look at addition and subtraction, for instance, those are inverses because addition will undo subtraction and subtraction will undo addition. So if we add 5 to something to take it away, we would subtract 5. So that's why we call them inverses. This whole idea of inverses, we can use that in this fact family idea. It's not a huge deal. The students use it more so later, once again without really realizing it. They don't actually put together a whole lot of fact families, they just do it. They use factors, they use different sums, subtractions, differences, things with division too. So they're not going to be asked to do a whole lot of fact families and come up with them, but it does come up in this section, so I just wanted them to be aware of it. You can take 3 numbers, for instance 2, 3, and 5, and you can take 4 facts from those numbers with addition and subtraction. As we can see here, we have 2 plus 3 to get 5, and then all they do here is switch the order around. 3 plus 2 also gives you 5. 2 subtraction facts. 5 minus 2 will give us 3, and 5 minus 3 will give us 2. So just a different way to relate some things together. And one other question I asked them at the end of this slide: what other 2 common operations are inverses? Clearly it's division and multiplication. So knowing that, old student. Knowing that, I had them put together a fact family for multiplication and division with these numbers 2, 3, and 6. So real quickly here, they immediately came up with 2 times 3 equals 6, 3 times 2 equals 6, and then our division ones, 6 divided by 2 equals 3, and 6 divided by 3 equals 2. So that's how we would create a fact family with those 3 numbers with multiplication and division. Our next property is called the commutative property. This one and the associative property, which we will get into, they are often confused. So we're going to have to make a clear description of both of those and figure out what the difference is here. Commutative property. We would say that addition and multiplication are commutative. And the reason is because if we look at addition, if we add 2 numbers, the order in which we add will not matter. For instance, 3 plus 5 gives us 8, but so does 5 plus 3. If we switch these orders around, we still get the same answer. We still get 8. So for addition, it doesn't matter the order. And that's the big idea here. That's why I underline order. So commutative is all about order. If the order switches with addition or multiplication, it doesn't matter. So moving into multiplying, if we multiply 2 numbers together, the order in which we multiply won't matter either. For instance, 3 times 5 will give you 15. Well, so will 5 times 3. That will give you 15 as well. So remember, commutative, order. That's the big idea there. That's how you connect the commutative property with order. That's the big idea. So, does subtraction and division, do those work with commutative property? Well, we'll take a quick look. If we take 5 minus 3, we get 2. Does changing the order of the subtraction matter? Yes, it does, because 3 minus 5 does not equal 2. We know that 3 minus 5 is negative 2. Subtraction is not commutative. Division. 6 divided by 2, we get 3. Does changing the order matter? Yes, it does, because 2 divided by 6 is not 3. 2 divided by 6 is 1/3. Division is not commutative. Remember, addition and multiplication are. Most of the properties that we talk about only apply to addition and multiplication. Alright, identities, that's our next property. Also, we're going to be talking about addition and multiplication here. What makes this statement true? 3 plus what equals 3? Well, that's got to be a 0, because if you add 0 to anything, you get the same number. That's the whole idea about the identity here. So we say that 0 is the additive identity, since when you add it to a number, you will get that same number back. So thinking about that with multiplication, what would make that statement true? Well, 3 times 1 will get you back to 3. So, here's a big word that the students like. 1 is called the multiplicative identity. So, because when you multiply by 1, you always get the same number that you started with. Alright, next, the associative property. Often confused with the commutative property. We're going to go over why it's different. Whenever we see parentheses, we know that we have to do whatever's inside the parentheses first. So, in this case, we have 2 plus 3 inside, so we got to add those first. That's a 5. 5 plus 4 will give us 9. So this is a true statement. Now here's where the associative property comes in handy, or comes into play. All we did here was take these parentheses and put them between the 3 and 4 this time. So we just kind of shifted them over. Let's see if we get the same answer. 3 plus 4 is 7. Plus 2, we still get 9. Now just notice the order of the numbers did not change. 2, 2, 3, 3, 4, 4. The only thing that changed is where we put those parentheses, and we still got the same answer. So addition and the associative property, they work together. And once again, like you probably figured, this also works for multiplying. We have to do this first. 2 times 3, we get 6. Times 4 gives us 24. Now if we shift our parentheses over from here to here, we do 3 times 4, we have 12. Times 2, we still get 24. Alright? And once again, notice that the order did not change with the numbers. 2, 3, 4. The only thing that changed is where we put our parentheses. We still got the same answer. Last property, very easy. Students use it all the time. The zero property of multiplication. As you could probably guess, all this says is that any number multiplied by 0 is going to give you 0. Quick example. 3 times 0 equals 0. Alright. In your books, on page 16, we have a summary of all the properties that we went over. Remember, this one talks about changing the order with adding or multiplying, and it doesn't matter. A plus B will equal B plus A. A times B will equal B times A. Associative property, that's all about taking your parentheses and shifting them over, but the order will not change. A, B, C, A, B, C. A, B, C, A, B, C. Order will not change, but your parenthesis location will change. Identities, remember that the additive identity is 0, multiplicative identity is 1, And zero property for multiplication, anything times 0 will be 0. So real quickly here, we'll go over a couple examples. And if you use that chart on page 16, it makes this easier. 5 times 3 equals 3 times 5. That's the commutative property. Order. Here for B, the order of the numbers is not changing. 3, 4, 5, 3, 4, 5. But we do notice that the parentheses switched. That is associative. Six plus 0 equals 6. Well, we started with 6, added 0, and we got 6 again. That's an identity, additive identity, to be more specific. And 6 times 0 equals 0. That I'm not going to write out, but that's our 0 property for multiplication. And which property can we use to find each unknown number? Well, 8 plus 0 will give us 8. That's an identity. That's the additive identity. 1 times 9 will give us 9. That is another identity, but the multiplicative identity. And 10 times 0 will have to give us 0. That's our 0 property for multiplication. Okay, moving on. This one tripped up some students. We're not looking for numbers here. We're not looking for calculations. I know what the answer to this problem is. It's 1500. What we want to do is look at this step here and this step and see what changed. Well, it looks like 15 and 25 switched spots. The order of the number changed. So that's commutative. Alright, and then from step 1 to step 2, looks like these parentheses switched. Order of the numbers did not change. 4, 4, 25, 25, 15, 15. This would be associative. And our last step here, last two steps, all we have to write here is that we multiplied 4 times 25. So here you could write multiplication. And for here, all you have to write is answer or solution, because that's what it is. And our last example was a challenge problem, just like the last one. So from A to B, what's changing? It looks like the parentheses changed, but the thing inside the parentheses did not change. So this is not the associative property. This is actually the commutative, because the order of the numbers changed. 4 and 4, 8 and 8, 25, 25. So this is commutative. And now from B to C, we can see that these change spots. And the thing inside the parentheses changed. This is associative. And then we can finish it out just like the last one. We multiplied 25 and 4 to get 100. And then we got our solution. So here we could write multiplying. And then here we could write answer or solution. I do not have the assignment with me at this time, but it is out on the homework link if you want to see it. Once again, this was lesson 2 for 7th grade.